as the question says, figure shows a small body of mass m placed over a larger mass capital M whose surface is horizontal near the smaller mass and gradually curves to become vertical. The smaller mass is pushed on the longer one at a speed v and the system is left to itself. Assume that all the surfaces are frictionless, then find the speed of the larger block when the smaller block is sliding on the vertical path. Now friends, what will happen in this question is that both are at rest, but the small m is given a velocity v in the horizontal direction, due to which it will actually climb up this block, and when it will come here, it will, due to the force between them, this m will actually start moving in the horizontal direction with some velocity in order to conserve the horizontal momentum, since there is no external horizontal force acting on the system. And the point where this smaller block will be traveling or having only the vertical motion, then the horizontal velocity of this small m as well as capital M will be equal. So now let us solve the first part, which is find the speed of the larger block when the smaller block is sliding on the vertical path. Now if the block is on the vertical part, both will be having the same horizontal velocity. So it will be mv, that is the initial momentum, to be equal to m plus m into v1. So we get the velocity v1 to be mv upon m plus m. Moving on to the second part of this question, which is to find the speed of the smaller mass when it breaks off the larger mass at height h. Now friends, it would have been the case that this block could stop at anywhere where it is trying to go up. But the thing is that they have given this in the question that it breaks off the contact. So it means that the kinetic energy must have been greater than the change of potential energy up to this point. That is why it was able to cross it and break off the contact. So keeping that in mind, let us do the energy conservation over here. So we are having the initial kinetic energy as half mv square and the final one being half capital M v1 square, where v1 is the horizontal velocity there, plus half m v2 square, where I have taken v2 as the total velocity, considering the v1 as well as the vertical motion, plus mgh. Now this is the potential energy, because up to here it will be converted into potential energy as well. This gives me the value of v2 that is asked in the question to be m square plus mm upon m plus m whole square minus 2gh whole to the power half. Now friends, let us move on to the third part of this question, which is to find the maximum height from the ground that the smaller block ascends. Now since it is going to break off the contact, it will go up to some height and will come back. Let us take this height to be h dash. So the maximum height will be h plus h dash. So let us do the same. Now friends, I can take the vertical velocity, that is vy, at the point of losing contact to be v2 square minus v1 square. So I have vy square to be m v square over m plus m minus 2gh. Moreover, when it is actually leaving contact from this point and coming to this highest point, it will come to rest in the vertical direction. So I can say that half m vy square, that is the kinetic energy there, will be converted to mgh dash. Now this is because of the vertical motion. So I get the value of h dash to be vy square by 2g. Let us mark it as equation number 1. Now as I explained before that the total height above the ground will be h plus h dash. So it comes out to be h plus vy square by 2g, giving me the value of capital H to be mv square by 2g into m plus m. So this is basically the answer for the third part. Now the part is show that smaller mass will again land on the bigger one. Find the distance traversed by the bigger block during the time when the whole smaller block was in flight under gravity. Now friends, this block as well as this capital M block are having the same horizontal velocity at the point when this block actually leaves the contact with the bigger block. So this means that when it goes into the air, they both are having the same horizontal velocity. That is Vh1 is basically equal to Vh2. And since the velocity is same, they will cover the same amount of distance in same time. And hence when it will return back, the capital M block would have covered the same distance as it would have covered by that time. So I can write it as SH1 will be equal to SH2, that is the horizontal displacement. Now all I need to do is to find the time for which it had been in air and take out the distance that is traveled by capital M. Now to find the time, I need to employ the first equation of motion. Now the final velocity, this small t is just when it breaks off the contact and reaches the highest point. So final velocity is 0, and I may write it as 0 equals to Vy minus Gt, giving me the time to be Vy by G. But friends, this is the time it took to reach the highest point. But the time taken total is twice of t. So I can write down that capital T is basically twice of t. Now friends, I can write the value of small t from that to be 1 by g capital M v square upon m plus m minus 2 gh whole to the power half. Now I have already mentioned that capital T is twice of t. So the horizontal distance will be simply the velocity into time, that is capital T, and the velocity will be horizontal one, so it's v1 into t. That gives me the distance to be actually 2gv into mv square minus twice of m plus m gh whole to the power half upon g times m plus m whole to the power 3 by 2. So this is actually the difference the distance that has been asked in the question.